In this video, we'll see how shifting operators behave in C programming language. First of all, we should always remember that the shift operators operate only on integers. They are legal to operate on integers only. There are two shift operators in C language. This is left shift operator. Okay. This one is left shift operator. It means bit pattern of the operand gets shifted towards left hand side by 1 bit position. On the similar lines, this represents double greater than symbol. We call it right shift operator. Okay. Now recall, in case of Turbo C, integer or int data type was of 16 bits, whereas in all modern Linux operating system, their distributions, by default int data type is of 64 bits. Now here, as an example, a typical behavior of left shift and right shift operators, I have assumed that the machine is of 16 bits. So suppose x equal to 5, and if we apply left shift operator, this means the value of x is to be shifted towards left by 1 bit position. So this one would come here, and this one would come here. This 0 would come here, which is shown here. You can see. So this bit representation is nothing but decimal integer 10. So shifting an integer towards left hand side by 1 bit position multiplies the number by 2. If you shift it towards left hand side by 2, it will be multiplied by 4. So every single bit position shift towards left hand side makes the number double. On the similar lines, if an integer is shifted towards right hand side by 1 bit position, it gets halved. It means it is divided by 2, but this division is integer division. So this 1 goes out. You can see here. This 0 becomes the least significant bit, which is here, and this 1 comes here. This represents 2. Okay, and we assume here that there is infinite supply of zeros from the left hand side, and if you shift towards left hand side, we assume that there is infinite supply of 0 from right hand side. Okay, now strictly speaking, what should happen if we shift 1? Suppose here x equal to 1, so this bit is 1. If we shift it towards left hand side by 15, and if the integer size is 16 bits only, then this LSB becomes the MSB, and in case of most computers, when most significant bit of a register becomes 1, the number is treated as negative. Okay, and all negative numbers are represented in 2's complement form. So it should now convert this x equal to 1 into minus 32,768, because this is the 2's complement representation of this number. So it is not guaranteed what would happen if you are using a 16-bit compiler under 32-bit machine across the platforms. It depends on the implementation. So be sure to shift an integer towards left or right hand side by only those number of bits which results in no overflow. You can say, by overflow I mean here that the most significant bit should not become 1. Then the results are guaranteed. Okay. If you declare an integer, unsigned integer, that is the most significant bit is also used to represent positive number, then the issue is different. It may give you the correct results. Okay, now let me demonstrate through some example. I have already made some program, and I will just demonstrate. Now here, what is written here? You can see I have written this printf 5 shifted towards 1 bit position. This is 5 shifted towards right hand side by 1 position. And then here what I have written is it would expect you to type in two numbers. One is number, integer number, and second, how much amount of shift you would like to give it to it. Okay. So let me execute the program. Now I can see here it is 5 shifted towards left hand side by 1 bit position, number gets doubled, so it is printing 10. Now this 5 shifted towards right hand side by 1 bit position, it is printing 2. Okay, it is printing 2. Though 5 divided by 2 should be 2.5, but here it is integer division, so it will result in an integer which is 2. Now it is waiting for us. It is in this statement, it is waiting for us to supply two integers. One is number, another is shift. And in next statement, printf function, it is shifting the number which you type at the keyboard towards left hand side by how many bits? The number of bits you supply here. Similarly, the same number would be shifted towards right hand side. Okay, and the result would be printed. So now suppose I type same example of 5 2. So what is it printing? Number is 5, so it is shifted towards left hand side 2 times. It means 5 multiplied by 4, which is 20. Now in the next line, it is, you can say, shifted towards this one. So once it shifts towards right hand side by 1 bit position, it is halved, which becomes 2, integer division. Another time, once more it is shifted towards right hand side, the result is 1, because 2 divided by 2, the result is 1. Okay, so in this way we can make use of shifting operators, but one thing you should always remember, that shift the integer only by that much number of those many bits, which does not result moving of bits beyond its limit. Okay, that is all in this video. Thanks for watching.